Hey everyone, welcome back to my channel. This is another YouTube video in the C++ series, part 6. And we're just going to go into basic data structures, right? When we're making programs, there are going to be times when we want to store information in a structured way that's easy for us to access and use. And that's where these data structures come in. Now, these are the ones that I'm going over mainly because you're always going to have to use these. Even if you're like a beginner, you're always going to see arrays, you're always going to see like dictionaries or hashes. But yeah, essentially quick going into an array, or no, in fact, I'll share my screen and I'll show you what I mean. And in my last video that I was saying, like, I was trying to get this video out to you last week, couldn't do it. But I did link my friend's video going over this kind of stuff, and it is really good. So if you didn't check that out, you should check that out. If you did, that's great. You'll understand this a lot easier. Also, I have the README. For each video I make, there's a new chapter in the README, or there's a new README chapter inside of the repo, the C++ series repo. I think I can link, can I link that here? I mean, if I can link it here, it's gonna be here. If I can't link it here, it's not gonna be there. But no matter what, you can count on it being in the description down below. Now let's get into it. I think it's easier if I do this, because now you'll see it recording the screen and me doing, and then I do that. And it just has to be in sync, and that's all we need. So I'm gonna start this off the same way we always started off. We need to include the stream, input output stream. And let us, we'll talk about arrays first. Right, our basic main function, which is what we'll use. Arrays store collections of data, normally of the same type. If we think back to, I guess, the chapter 2 about types, then we can look at like, okay, we had an integer. Anytime we created a variable that was an integer, like age, and we set that to something like 21, our program is allotting space in memory to store this variable, right? Which takes up about 4 bytes of memory. So then you can think like, okay, what we can do is we can create an array. Like maybe, let's say we want an array of tickets. Everyone has a unique ticket with a specific number on it. This is one of the ways that we can declare an array. So we can do int tickets, right? And then we make sure we put our square brackets here, and we can set that equal to like 42, 4, 5, 6, 7, 8, 9, and 10. I think this is fine, right? Right, so we have this as has, cool, you can hover it over, see some specifics in here. But yeah, this has 8 elements in it. Now, the thing about arrays in C++ is once you declare an array, you cannot change the size of the array, right? You can update the elements inside the array, right? But you cannot change the size. I'm just gonna write that quick note here. Right? Boom. Arrays, their size is not mutable. That means we cannot change the size of an array. Another way that we can declare an array is if we give it the size beforehand. Like we can do something like int tickets and then pass in the size of the array we want in the square brackets. And this is also going to create an array, you know, that's pointing to 8 spaces, 8 blocks of elements in memory that are adjoining, that are right next to each other. And then let's say if we wanted to update or change a value inside the array, you can do something like this. And quick thing, arrays are 0 index, so to access the first element in an array, we have to access it at index 0. So we can do tickets index 0 is equal to 42. So we're going to kind of go for this kind of thing over here. Right, and then real quick, just for us to see it, we could right, and I'm gonna, ooh, 1 second, almost forgot that part. See, I had my red squigglies over here. So now let's open our terminal, let us compile it. And once this compiles, we'll be able to, okay, yeah, take your time. Who prints 42, right? Right, cool. So another thing that we can do, if we wanted to populate the rest of the items without having to manually write it out, like a good way to work with arrays is to use loops, right? That's why we went over loops before, now we're diving into arrays. So we can do the same thing that we've done in the previous video, just loop int I, we're gonna set I equal to 1. Since we have the 0th index already accounted for, I'm just gonna wanna populate the rest of the array with these new values. So in I equals 1, as long as I is less than, oh, okay, real quick, if we want to get the length of this, things work a little differently in C++, and I remember this clocked me a while back, but right, if we, let's say we want to get the length of this array, we can do something like this, int tickets length, and we'll set that equal to size of tickets, right, over size of and then that's how we get the tickets length. And then if we wanted to, look, I can print that out. Tickets len should give us right, tickets len should give us, we have to compile it again. Now let's run it, 8. So that gives us 8 because that's the size of the array. And it's good to do something like this because you don't want to write something like this every time you iterate through the array. Alright, so let's bring this back. So as long as I is less than tickets length, the length of the tickets array, then we can increment I. And yeah, let's just set tickets at I to I plus 3, because I think that is going to be what gets us this, right? So when we start off at 1, I is 1, 1 plus 3 is 4, that'll give us this, and then when I is 2, 2 plus 3 is 5, it'll give us this, and so on and so forth, right? So this will populate the array with the information we want, and then we can kind of do the same thing, right? You could just grab this line of here, grab this line of here, and then yeah, we can just print out tickets at that index. So we can just this is ticket number, or this ticket number is, and then we could put tickets at I, and we could put a new line over there, something like that, or we could put, okay, no, this is fine, yeah, And let us try this. And file. It's a great thing when it doesn't break. Oh, wait, what happened? Oh, shoot, yeah, whoops. Alright, so this we're gonna have to start at 0 because we want this to go back again. So, oop. So let's try to compile one more time. And let's try to run it one more time. There you go. So this ticket number is 42. This ticket number is 4, 5, 6, 7, 8, 9, and 10. If we want to do something where we could put at index, whoops. And then put I over here. Okay, so now let's try that one more time just so you could really see what's going on. And compile. Right? This ticket number is 42 at index 0. So we're seeing the index of the array at index 0, the ticket number is 42. So on and so forth, we can keep going like that. Yeah. Cool, right? So those are arrays. And the next thing that we want to go over is vectors, right? Okay, so vectors are a template class that's unique to C++, and they implement the list interface. The cool thing about vectors is that they are mutable. They can change in size. So like, let's say as you add elements to a vector, it will grow. As you remove elements from the vector, it will shrink, unlike the array. So the way we can do this is if we include vector, now we'll be able to use vectors inside of our program. And I know the text editor takes some time to adjust and define that code. But yeah, so like this part, we have arrays, we have vectors, right? So like, let's say if I have a vector with 4 items in it and then I add one more thing to that vector, it'll just double the size of space that the vector has, or the vector needs, in memory. And also the reason why vectors are able to do this, the reason why vectors are able to change is because they use heap memory, which supports dynamic memory allocation. And that's where all the power comes in. Cool. So, I would say vectors, they're mutable thanks to the fact that they use heap memory. I'm not sure if this is a good sentence, but this is about coding. All right, cool. So let's say we want to make a vector, we want to hold out an array, or we want to hold a group of frozen yogurt toppings. Why not? And let's do it. A vector, we're going to say the data type just like with arrays. We're saying like this is an array of integers. For vectors, we're saying this is a vector, we're going to hold strings, right? So cool. So this is a string vector, and I guess since we're holding frozen yogurt, we can call it froyo toppings. How about that? Yeah, we have our frozen yogurt toppings. Let's print out a message if we want to like cout enter 3 toppings to put on your frozen yogurt. And I'm gonna do that, and then we can loop. So let us do another for loop. We want to put in 3 toppings, so we know that it's 3 that we want. So for int I is equal to 0, I is less than 3, I plus plus, right? And we're gonna do a few things here. We're gonna create, like, you know, just a string. That's just a froyo topping, right? And then we're going to try and collect that froyo topping. Whatever the user puts into the terminal, we will set that to our current froyo topping, right? And then after we do that, we can use the froyo toppings. We'll do dot push back, and this will append the froyo topping in question to the end of the froyo toppings vector. So froyo topping singular. Cool. Right? So we have a froyo topping, and then we have froyo toppings dot push back froyo topping. And then if we want to see, like, look, we can make something like one froyo with, oops. And so we're gonna say like one froyo with, and then we're gonna say all the toppings, and then we're gonna say coming right up. Then we could loop again for I is equal to 0 as long as I is less than froyo toppings dot size. Now this is something that we can use with vectors. We just use dot size. This will give us the size of the vector, and then we can increment I. And right now we can just, alright, cool. Just to be a bit faster, I'm not gonna try and do anything fancy with the printing. And I'm also gonna give it like a space in between, right? So here, go, we'll say like this froyo topping, or say it's like, whoops, there we go. We're gonna say this froyo toppings at that index, and then we can put a string here. Come and write it. Cool, let's try it out. And let's see what happens. Let's compile it. Does it break? It does. Wow, this is a good run. This is a good run. And let's see. We're gonna want some jimmies. We want some blueberries, and how about pineapples? Just like little chopped up pineapples. So one froyo with jimmies, blueberries, pineapples coming right up. Cool. And that's a vector. These are vectors over here. Super cool. And all right, so since we've gone over arrays and vectors, I'm also going to get a little bit into dictionaries in C++. These are also known as hashes, hash tables. Essentially, these are like a whole bunch of key value pairs. I mean, some of them are key value pairs. A cool thing about C++ is that they have 8 different implementations of, like, you know, some type of dictionary. You have like sets, multi-sets, maps, multi-maps, and then you have unordered sets, unordered multi-sets, unordered maps, unordered multi-maps. Essentially, the difference between unordered and ordered is just that ordered means that they're going to be sorted. Unordered, whenever you add something to one of, like a set or a map, an unordered set or unordered map, it's just going to be placed in there randomly. If you want to think about kind of big O notation wise, if you're going to try and access something from like an unordered map, that's going to be constant time, it's going to be O of 1. if you're gonna try and access something from an ordered map, then that's gonna be logarithmic time. That's gonna be O of log n. We're gonna start going into solving problems, so I think big O notation is very good, very important to understand. I'm gonna link my friend's video about big O notation. In fact, the playlist, I think it's a playlist. I'm just gonna put the first video that I'm coming to mind about big O notation right there. He explains it very, very well. Me just linking people's stuff without asking them for it first. But that stuff is gonna be really good. You're gonna understand it. What I'm gonna go into now with these dictionaries, I'm gonna go over an unordered map because that's gonna be one of the things that you use. Unordered maps. Right? So if we want to use an unordered map, I think we gotta include this as well. So let's go over here, include unordered map, and close this here. So now we can use unordered map. Unordered map. There we go. I'm gonna show you kind of like the structure of what this kind of looks like, right? If we have like a structure like this, like maybe we have some kind of map, right? And then the structure is going to be like a key value pair. If you have like, let's say like name Jackson and right, and what is it? Species human. See, okay, so like that kind of thing. And then if we want to access the name, then we can do some map, and then in brackets we put name, and then this is gonna evaluate to Jackson. Essentially, that's what should happen. I'm gonna just go into it. Okay, so let's say we want to make an unordered map. This is gonna hold like someone's name and then their age. So this is how we declare it. We'd have unordered map. And we also, just like with a vector, how we have to specify that this vector is gonna hold strings, this unordered map is going to have keys that are names. So this is going to be name, and keys that are names that are strings. And then the integer is going to represent the age, right? And you could just say people. Cool. What we can do here is if we have people, and let's bring Jackson back. Why not? Jackson. We could set that to 22. We can have okay. Kim is like, I don't know, 17. And there we go. And then let's also get James, who is 20, and Janet, who's I guess also 22. Okay, so these are the people that we have in this people unordered map, and we can print out one of the things like size also works for this. So if we want to see how many people or how big this unordered map is, we can do people. Oh, let's print it. We have right. So we have people size and in our people map. I don't know. Cool, right? So this is telling us This will tell us the size of the map, right? If we ever want to use that. If we want to say how old someone is, right? We could do see out James. Oh, James. Oh, we could do James. James is people at. At is going to be how we get the value by passing in the key. So we're going to pass it James, right? To get the value of this, right? So remember, some map, and then like we pass in whatever the key is, and then that will return the value, right? So people at James, which will return 20. So then this should be James. Oh, this should be James is 20 years old. I know I could have done that up here. I missed my mark, but that is okay. Oh, what did I do? What did I do? Oh. Okay, so now let's try and run this to see what happens. Okay, and let's print it. I forgot about the toppings. Just kind of do the same thing. Blueberries and pineapples and jimmies. And there we go. So everything ran. We had 1, 2, 3. So we had everything that happened in this program. We have our tickets with the arrays. We have the vectors with our toppings for the froyo. And then look, we have 4 people. We have 4 in our people map. I can change that to 4 people in our unordered map. Okay. And all right, so then James is 20 years old. Right, cool. And then we see that James is 20 years old. Right, okay. Another thing that this is useful for in certain problems, you know what? In fact, I will start making some problem solving in C++. I think I'm gonna find a problem that would benefit from me using some of the stuff here today, just so you can understand, like, you know, because like now you have all the information that, oh, I can stop recording the screen. I can stop recording the screen. It's finished. Holy cow. Nice. Okay, everyone. Yeah, that is it for part 6 of the C++ series with arrays, vectors, dictionaries with the unordered map. There's also all the things that I said before, like sets, unordered sets, multi-maps, right? More information about those are in the README. The README. That will be in the description below. But yeah, this is everything that you need to kind of start working your way through problems. That's about it for the video. This feels so weird because I don't normally get through 37 minutes. 37 minutes. Not that many hiccups either. Doesn't happen very often. But yeah, these are essentially the starting point, the starting stuff that you need to start actually doing those like problem solving stuff, like with LeetCode, HackerRank, and stuff like that. So now I can start making those videos as well, just problem solving with C++. A thing I would ask you to do before starting those problems with me, again, link in the description below, my friend's video about big O notation, just so you can understand what is going on. Time complexity, space complexity, you need to know what that kind of stuff is when you're solving your problem, right? Because you could start solving a problem with the brute force, and then you need to be able to speak through why this is not an efficient solution and how you can optimize it, what ways you can use to optimize it, and like what are certain trade-offs when you have like, I guess, 2 different kind of like, you know, optimized solutions. But yeah, that's about it. Lots of stuff happening. Good news coming your way. I have good news. I'm very happy about it. But that's about it for the video. I'll give you a high five because this one took some time. We made it this far. We're really making progress here. And I'm gonna go. Thank you, everyone. See you next time. Another high five for sitting through this part. And yeah.